Hi, welcome. This is our step-by-step on how to factor. Here is the equation that we've been asked to solve by factoring. And so I'm going to take the equation and I'm going to write it out all by itself so it's out of the way of the problem and I can work with it. This is a quadratic equation, and in order to solve quadratic equations, I have to start by writing the standard form of a quadratic equation, and I will want to convert the equation that I am looking at into standard form. There's standard form for the quadratic equation. This is not in standard form, and what I need to do is I need to remove this 12n from the right hand side. This will allow me to have a 0 there and everything else on the other side exactly like my standard form shows. All right, I have got my quadratic equation in standard form, and now I need to start factoring. I'm going to use a process called sum and product. It's called sum and product because I'm going to take the sum of something, I'm going to add stuff, and I'm going to take the product of things. I'll be multiplying. In order to know what I'm going to be adding and multiplying, I need to find out what the values of A, B, and C are from my standard form. Looking at my standard form, A is always the coefficient of the squared variable. That is, it's the number being multiplied by the variable that has the exponent squared. Looking at my equation, the coefficient for this n squared term isn't listed. Whenever a coefficient isn't listed, it is 1. I need B. From my standard form, B is the coefficient of the x term. Looking here, the variable by itself. Looking here at this equation, my variable is n. The n by itself is here in the middle, and my coefficient would be this negative 12. I need to find out what C is, and looking at my standard form, C does not have a variable of any kind. It is the constant. Looking at my equation, the only number that doesn't have a variable on this left-hand side is this number right here, 32. And so my constant C is 32. Time for me to start finding the product of things. I'm going to find the product of A and C. That is, I'm going to take the value for A and I'm going to multiply it by the value of C. A times C is 1 times 32. That is 32. The next thing that I need to do is I need to list out all of the factor pairs, all of the pairs of numbers that I can multiply together to give me a positive 32. 1 times 32, but also the negative versions, negative 1 times negative 32. 2 times 16 works, as does negative 2 times negative 16. 3 doesn't work, but I believe 4 works. Let me check my handy dandy calculator really quick. 4 times 8, my calculator is showing, is 32. And so 4 times 8 will work, as will negative 4 times negative 8. If I keep going like this, I don't think I'm going to find any other factor pairs, and so I'm going to go ahead and stop here. Time for me to do the sum, which is the other part of the name of this method of factoring. I'm going to take each one of these factor pairs that I have written and I'm going to add them together. 1 plus 32 is 33. Negative 1 plus negative 32 is negative 33. 2 plus 16 is 18. Negative 2 plus negative 16 is negative 18. 4 plus 8 is 12. And negative 4 plus negative 8 is also, negative 12. Now, looking at all these factor pairs and sums that I have just created, I need to find the factor pair who add together and give me the value for B, negative 12. That's this pair, right down here. And so my factor pair that's going to be very useful for this one is negative 4 and negative 8. I'm going to replace this middle term right here with 2 terms whose coefficients are the factor pairs that I have identified in the previous step. And so I'm going to rewrite negative 12n as negative 4n minus 8n. The rest of my equation remains unchanged. The next step for factoring is I need to create some groups to help me keep things organized. To create groups, you're going to write two sets of parentheses. Give yourself some space because we're going to write inside of them, and please put an addition sign between those parentheses. It's addition because it must be addition to make this work. Please do not use this sign here. That is not the correct sign. It's addition because it must be. The next step is I'm going to fill these groups, and I'm going to fill them with two terms each of the expression that I had above it. So I'm going to take this term and put it in here, and this one, and then the next one, and then the next one. Now that I have my groups, it's time for me to start actually looking at the factors that I need for each individual term. That is the things that I need to have in order to multiply together and give me these individual values. N squared is achieved by taking n times n. Negative 4n could be written as negative 4 times n. Sure, we could go into 2 times 2 is 4, but I'm not going to at the moment. Now this one. I could do negative 8n, but notice how here we've got negative 4 and negative 8. Negative 8 appears as one of my factor pairs, so I guess I will go ahead and leave this as negative 8 times n. But now 32, I get my choice of a bunch of different factor pairs. All of these are available. Which factor pair is the best one to use? The best factor pair to use is going to be this factor pair right here, the one we've already been using so far for this problem. We've used it once, it was helpful, it's going to be helpful again. There I've listed all of the factors for each individual term. Now I need to find the one that's in common with these two in this group. This group has n as its common factor between those two terms, and so I will write it by itself, just n. We're not going to multiply them together. And then in parentheses, we're going to write down what's left over when we ignore the common factor. That's what we have. This plus sign is going to make its way down unchanged. And for the next group, we're going to again find the factor that they have in common. In this case, the negative 8s. Writing the common factor down and then creating our next group. Inside that next group, we will write the factors that we have left over when we ignore the common factor. And our expression now looks like this. Notice that in doing this, we have created in these two terms factors that are in common between both of them. This means that this particular factor here is common to both of these terms, and so I can write it out in front much the same way that I wrote the common factor out in front this way. But because this factor has two terms in it, I need to write it in parentheses. There's my group that's representing these black groups that I've been carrying from before, and I'm going to write in what's left over from each term when I ignore the fact that I had group, when I ignore the greatest common factor. Excuse me. Don't forget to bring back down your equals 0 because we are solving. The last step to factoring this, because I swear we are almost done, we have one little thing left to do, is to use something called the zero product property. And what the zero product property says and allows you to do is this. If you've got something, I don't know what it is, but it's being multiplied to something else, I don't know what that is, but the result is 0, then one of those two things had to have been 0. And so when I have a setup where I have two things multiplying together equaling 0, I am allowed to rewrite it and look at each factor by itself equaled to 0. Here, if I add 4 to both sides, I will solve this equation and find out that the original quadratic that I have written up here is 0 when the value of n is 4. Looking at this factor, if I add 8 to both sides to isolate n, it's going to tell me that this quadratic up here that I've been working with is 0 whenever n is 8. And that's how we solve an equation, one of these kinds, a quadratic equation, by factoring.